We are going to finish now the lesson on the polar equation of conics, and we're going to do that by just simply comparing it to a rectangular system and kind of determine which method works best in different situations. There's an assignment. If you look on Google Classroom, there is a GPS for you guys to do. So this won't take long today. So what do I have? I have the polar form, theta and r, of the particular curve. I don't know which curve it is. I do know, obviously, it's probably based on one of the conics. And what I need to do, of course, in polar form is to get that to the number 1. But what if I didn't want to do that? What if I'm much more comfortable with the rectangular system and I decided that I'd like to translate this to the rectangular form? Well, we can certainly do that, and that's a process of algebra. One way we could do, first thing I would probably do is I notice there's 12, 4, and 8 are all multiples of 4. So that's just a case of simplifying a particular expression, and that is what I chose to do. My motto is that smaller numbers are less likely to make a mistake than larger numbers. From there, I would probably move this denominator over to the other side of the equation. I'm going to do that through multiplication of both sides. I now am looking at this. I would probably distribute the r to this expression right here. That leads me to r plus 2 r sine of theta is equal to 3. From there, I would probably recognize that r sine of theta meant something, and that's for you guys to remember that's exactly what y is equal to. So that leads me to r plus 2y equals 3. From there, I think I'm going to move the 2y over to the other side, and now I've isolated the r. At this point in time, I think I'm going to square both sides of the equation. So I do that. Distributive property, 3 minus 2y times itself does equal this. Hopefully I haven't made any mistakes. I'm sure if I have, you guys will catch me and let me know. From there, I do recognize r squared. So I'm going to substitute an x squared plus y squared in there. And now I'm back to something that looks very familiar from when we first introduced the conics in rectangular form. What's next? Well, I think I'm going to move the y squareds over to this side, bring all the y's over there, leave that constant over there. At that point in time, I think I'm going to complete the square. So I'm going to factor in -3 from those two terms right there. That leaves me -4y. I'm going to complete the square by taking half of this and squaring it. Now, when I add a 4 to one side, I must add a 4 to the other side. Most common mistake is you guys tend to forget that this 4 is being multiplied by this -3, so we must recognize that. From there, I clean up my left side. There we go. I clean up my right side. This being negative doesn't bother me at all. I know at some point this needs to be equal to 1, which is my next step. And I divide both sides of the equation, which means all groups of factors get divided by -3. And I end up with, there's a minus sign. That means it's definitely a hyperbola. The y is the positive term, and that tells us the direction of the hyperbola. And I am done. Now, look quickly. Make sure you guys can see that. That's a bunch of work. I went through it very, very quickly. But the most important thing is why am I doing what I'm doing? And that's what we really want to focus in with you guys is why do I do something algebraically? There's just no way to just memorize something. So the first thing to note, without a doubt, is that I think you need to understand that the x equals r cosine of theta and y equals r sine of theta directly relates to x and y. So what I really want to do is put myself in a situation where one of those, r cosine theta, r sine theta, can show up, and then I can use substitution. And there's ways I can do this that make it clean like this problem. There are other ways I can do this, as you learn when you establish identities, that you can take off in a multiple directions. And in theory, as long as you don't make a single mistake, you are still correct, but you might be creating a scenario where you don't recognize where you need to go from there. Now, the next thing I want to make sure is that there is nothing that directly connects r to x and y without there being involved some sort of cosine or sine. So I guess I could multiply both sides of the equation by a cosine or a sine, but that just leads me to trig functions showing up in various groupings that I'm trying to avoid. And that's when I remembered about the fact that there is, however, a relationship for an r squared. But When should I square? And that's my suggestion to you, which is always make sure you square wisely. Having gone from a single R to a double R, but I'm getting rid of that second R term through substitution, I now isolate the R itself with no other R's anywhere. That is probably a great time for you to square, because that leads to the fact of the R squared term shows up. And you should recognize that other than those two, this was the third thing that always helped us out. X squared plus y squared does equal to R squared. And from there, well, I'll be honest with you guys, that is just about the fact that if you really took the time to organize your work, if you've developed solid algebraic habits, then you're going to find yourself very, very successful eventually in calculus when it comes down to these potential problems that take close to a full page. And that's certainly how I remember college mathematics. So on that note, I think we have squared up the rectangular system and the polar system. I hope you're very comfortable about working your way through either system and jumping back and forth if necessary as you analyze conics themselves. Have a great day.